Greetings, pre-calculus students, to another day in our unit on the unit circle and trigonometry. We finished up trig graphs for the most part in our previous week, and now we're going to be moving into the last phase of the unit. Yes, this is going to be the last phase of this unit, and then we're going to have a summative. So in this phase of the unit, we're going to be talking about this idea of solving trig equations, solving trig equations, which you have actually done in a prior quiz. I have actually given you one problem in a previous quiz that involved you solving a trig equation. So more specifically, we're going to look at two types of problems today. Solving a trig equation without a calculator, so using the unit circle, and solving a trig equation with a calculator. So let's get to it. And we're going to skip these two slides. Actually, we're going to return to them in another. All right. Okay. And okay. So method one, using the unit circle. All right. Method one, using the unit circle. So, we've used the unit circle in the past before, right? We've been given an angle measure. We've looked up the angle measure on the unit circle, and then we've simply picked the xy value or y over x if it's sine, cosine, or tangent, respectively. Well, let's look at, instead of us being given an angle, let's see what happens if we're given the value already. We're given the xy value already in our answer, and we're supposed to determine what the angle was/is that would produce that answer. So here you'll see a simple equation. Sine of x is equal to radical 2 over 2. Okay, so sine of x is equal to radical 2 over 2. Okay, well, sine is equal to radical 2 over 2, all right, is equivalent to saying y is equal to radical 2 over 2, correct? Because sine is equal to the y value of the point on the unit circle. All right, so sine is equal to the y value of the point on the unit circle, which happens, okay, so you look at your unit circle, and you want to look at the points where the y value is radical 2 over 2, or square root of 2 over 2. Well, that happens at two angle measures, pi over 4 and 3 pi over 4 radians. Okay, so pi over 4 and 3 pi over 4 radians, okay? So once again, at these two angle measures, which I'm trying to think about the points off the top of my head, would be letter B and the other one would be letter E, okay? If you look at those 2 points on the unit circle, you would see that the y values of those 2 points are indeed square root of 2 over 2. Okay, so we would say our answer, or the solution to this equation, is x equals pi over 4 and 3 pi over 4. So there would be two solutions, okay, two solutions. So you typically want to list all the solutions, okay? You want to list all the solutions in the, that correspond to the given value, okay? So once again, sine of x is equal to radical 2 over 2, okay, is equivalent to saying when is y equal to square root of 2 over 2, because y is equal to sine of x is equal to the y value of the point on the unit circle. So you look up the angles on the unit circle, and it just so happens to be pi over 4 and 3 pi over 4 have those y values at those points. So our final answer for this equation would be pi over 4 and 3 pi over 4. So that's all you're doing. Okay, so once again, you're given the x and y value respectively, and then you have to determine what the angle measures are that correspond to that given x or y value. Okay, so these two problems I want you to try on your own. Okay, so these two problems I want you to try on your own. Cosine of x is equal to negative radical 3 over 2, and sine of x is equal to negative 1. Okay, so for cosine, remember, cosine would be the x value of the point, and sine of x would be the y value, just like we saw in the previous example. Okay? All right. Now let's look at something a little bit trickier. So sine and cosine are pretty straightforward because you're just looking for the x or y value respectively, and then going from there. Now let's look at tangent first. Okay, let's look at tangent first. Well, tangent is trickier, or it can be trickier, because remember, tangent is equal to y over x, right? Tangent is equal to y over x. Now, the reason why it's trickier is because more often than not, the answer that you're given Okay, so you're given square root of 3 over 3. That's already been simplified. Okay, that's already been simplified for you. If you remember back when you were evaluating tangent values, right, you would sometimes get something like this. Square root of 3 over 2 over 1/2. So you would have to simplify that. You would have to simplify that fraction to see what you would end up with. Okay, so this fraction has already been simplified. Okay, so that's why it can be a little bit trickier, because there is a certain degree of trial and error. Okay, there is a certain degree of trial and error. Now, we can narrow down our answer a little bit. And the reason why I say that is because if you notice, the value they give us, okay, the value they give us, come on, oops, sorry about that. There we go. The value they give us is square root of 3 over 3. Okay, that is the value that they give us, square root of 3 over 3. All right, well, there is a square root of 3 in the answer, right? There is a square root of 3 in the answer. Okay, well, that's good. So that means our answer, our final answer is either going to be something over 3 or something over 6. That's going to be our radian measures that we're going to be looking at. Now, the reason why I say that is because if you look at your unit circle, okay, if you look at all the points that are either like something over 3 or something over 6 as their radian measure, you'll notice that those are the only points that either have this as their coordinate, their ordered pair, or they have this. Okay? So in other words, those are the only points on the unit circle where you're going to have that square root of 3 as part of the point, as part of the coordinates of the point. And you need to have a square root of 3 in your coordinates in order to have a square root of 3 in the end. Okay? So you're going to be looking at either over 3 values or the over 6s. Okay? So I mean, for example, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, or pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Okay? So those are the ones that you're going to be looking at. Well, like I said, trial and error. Trial and error. Okay, so let's try the pi over 6 one first. Okay, so let's try the pi over 6 one. So pi over 6, question mark. Well, let's see. Let's test it out. So if we do the tangent of pi over 6, so that's y over x. Remember, that's y over x. So the y value would be 1/2, and the x value would be square root of 3 over 2. Okay. Well, let's simplify that. So we're dividing two fractions. So we have 1 over 2 times the reciprocal of the bottom. So 2 over square root of 3. So that gives us 2 over 2 square root of 3. Those 2's cancel out. And we're left with 1 over square root of 3. Well, remember, we're not done yet, because whenever you have a square root in the denominator, okay, whenever you have a square root of the denominator, remember you can get rid of it by multiplying the top and bottom by square root of 3. So we end up with square root of 3 over square root of 9. Well, what is the square root of 9? The square root of 9 is 3. Oh, so it looks like it worked. That's what we wanted. It looks like it worked. So it looks like pi over 6 is one of our answers. Pi over 6 is one of our answers. Now, there is another solution. Because remember, the unit circle, a lot of the points are very similar to one another. So one of the answers is pi over 6. Well, let's see. What is the other point on the unit circle? Okay. So what is the other point on the unit circle that has 1/2 for y and square root of 3 over 2 for x? Okay, 1/2 for y and square root of 3 over 2 for x. Where on the unit circle does that also happen? Well, it doesn't happen anywhere else. But 7 pi over 6 does work. Why? Well, if you look at 7 pi over 6, the y value is not 1/2, it's negative 1/2. But since both of them are negative, right? Since both of them are negative, the negatives canceled out. The negatives would cancel out and would produce the exact same answer, the exact same positive answer. So that means 7 pi over 6 would also work. Okay, so that's why the tangent ones are a little bit trickier. That's why the tangent ones are a little bit trickier. So like I said, there is a little bit of trial and error. Okay, there is a little bit of trial and error. And the problem that I was alluding to earlier was the problem from, I think, 2 quizzes ago, where I asked you what angle measures make tangent of x is equal to 0, or I think I said tangent of x undefined. That was the quiz problem that I was referring to that you guys have seen before, and some of you answered correctly. Okay, so now let's do cosecant is equal to square root of 2. Cosecant is equal to square root of 2. So this one is not as tricky as C. This one's not as trickier as C. So if you notice, cosecant is one of the reciprocal functions, right? One of the reciprocal functions. So if you recall, cosecant is the reciprocal of sine. Okay, so cosecant is the reciprocal of sine. Cosecant of x is equal to 1 over sine, or 1 over y, in other words, 1 over sine, 1 over y. So this is what we're going to do. We're going to use a little trick here. Okay, since cosecant is the reciprocal of sine, okay, so since cosecant is the reciprocal of sine, we're going to rewrite this as cosecant of x. I'm sorry. We can do this little trick. We can turn this into a sine problem by just taking the reciprocal of the given number. So I literally just took square root of 2 and I flipped it, or I put it under 1. In other words, I took the reciprocal of it. So the reciprocal of square root of 2 is just 1 over the square root of 2. Okay, so once again, I did because cosecant and sines are reciprocals of each other. Okay, cosecant and sines are reciprocals of each other. Just like secant and cosine is the reciprocal of each other, or cotangent and tangent is the reciprocal of each other. Well, let me simplify this a little bit because there is a square root in the denominator. So let me multiply by the square root of 2 to the numerator and the denominator, which gives me the square root of 2 over the square root of 4, and the square root of 4 is simply 2. So right now what we have here is, when is sine of x equal to the square root of 2 over 2? Well, that's not too bad, right? That's not too bad. We can easily find where the sine of x is equal to the square root of 2. So when is y, equal to the square root of 2 over 2? Well, if we look up the y values on the unit circle, okay, there are 2 points where the y value are equal to the square root of 2 over 2, and those would be pi over 4 and 3 pi over 4. So that would be our final answer. That would be our final answer. Okay. Now I want us to address a little quick thing, which is this idea of, well, how do you find additional solutions? How do you find additional solutions to your equation? Well, it's simple. You simply add or subtract 2 pi. Okay, so to find additional solutions, you simply add or subtract 2 pi. Why? Well, if you recall, 2 pi radians is the full distance, if you want to call it that, the full distance around the circle. So once you travel 2 pi radians, you have traveled a full circle around. So you end up in the exact same place that you started. Okay, so whenever you want to find additional solutions, you can add or subtract 2 pi. Okay, add or subtract 2 pi. So for example, let's say if we take the previous problem that we just did, which was x is equal to pi over 4 and 3 pi over 4. Okay, if you want to find an additional solution to that, like let's say you were asked, well, give me a third solution to that. All right, well, I can simply take pi over 4 and add 2 pi to it, right? Pi over 4 plus 2 pi. So in order for me to add these two terms, I do need common denominators. So 2 pi is the same thing as 8 pi over 4, right? 2 pi is the same thing as 8 pi over 4. So this gives me 9 pi over 4 as another solution, a third solution. And I could have done the same thing to 3 pi over 4 to have gotten a fourth solution, okay? So there are an infinite number of solutions at the end of the day, depending on, what you're being asked, okay? Depending on what you're being asked. Okay. So just a small thing, but important to remember. Whenever you want to find additional solutions, or let's say I asked you, find me a negative solution. Okay, find me a negative solution. Well, in order to find a negative solution, you could take that pi over 4 and subtract 2 pi to it. Okay, so you end up with pi over 4 minus 8 pi over 4. So pi minus 8 pi is negative 7 pi over 4. Okay, so that would be an example of a negative solution, right? Let's say, once again, if the problem asked you find a negative solution, you can do that by subtracting 2 pi. All right, so now let's look at using a calculator now. Okay, now let's look at using a calculator. So this is a method that you want to use when the values that are given to you are not on the unit circle. Okay, so when the values that are given to you are not on the unit circle. So here's a perfect example. You have sine of theta is equal to 0.7214. Okay, that is not a value that is readily or easily identifiable on the unit circle, 0.7214. Okay, so the way you do this is we're going to use the inverse function to this, which we've done before. If you recall, we have done before, and it's this idea of, all right, when this value is not easily identifiable on the unit circle, we're trying to solve for that variable, right? We're trying to solve for that variable, in this case theta, in our equation, and we can solve for it by taking the inverse sine of both sides, right? You take the inverse sine of both sides, and remember, you want to do this whenever you want to cancel out a trig function, all right, or undo a trig function to get a variable by itself. So you take this inverse sine of both sides, and you end up with just that variable, right? That theta in this case, or x, or whatever variable you end up with. So at that point, you end up with inverse sine of 0.7214 because we did it to both sides of the equation. And at this point, you would just plug it into a calculator, and it gives you 0.806. Okay? So plug it into a calculator, gives you 0.806. And you're done with that answer. All right? All right. So A you can definitely do on your own. Okay, so A you can definitely do on your own because it's just cosine instead of sine. So you just have to do inverse, inverse sine instead. On your own. Okay, now let's look at the cosecant one because that one's a little bit different. All right, let's look at the cosecant one because that one is a little bit different. For that one, you do have to be a little bit careful. Well, let's use the same trick we used in that previous problem with cosecant, or it could have been secant. It doesn't really matter. You can use this trick whenever you have one of those reciprocal functions. Well, let's see. Remember, cosecant is the reciprocal of sine. Okay, so cosecant is the reciprocal of sine. So I can rewrite this as sine of x is equal to 1 over 2.763 because they're the reciprocals of each other. And at this point, now you can just take the sine inverse of both sides. Okay, so take the sine inverse of the left side and the sine inverse of the right side. So you end up with inverse sine of sine x and inverse sine of 1 over 2.763. These cancel out. You're left with that variable in the inside the parentheses, so you're just left with x is equal to whatever inverse sine of this number is equal to. So you'd have to plug that into a calculator. Let me just quickly do that. Inverse sine. And calculators do have an inverse an inverse sine button. So you just have to look up for that inverse sine button to find it. If you have difficulty finding it, definitely let me know. or you can just use Desmos. Okay, so make sure it's in radians. So we got 0.370 if we rounded to 3 decimal places. Okay, so that's the answer that you should have gotten if you plugged it into a calculator. And that is in radians. Okay, so that final answer is in radians. That final answer is not in degrees. Okay, so it is in radians. So something to keep in mind. Because obviously we could find the answer in degrees as well. All right, C you can also do on your own. Okay, so C you can also do on your own because it's just tangent. So you would just use inverse tangent, and D as well. Okay. Okay. So A, C, and D, for example, too. A, C, and D, for example, too. You can just do on your own. There isn't really much else to say about it. A is inverse. You just have to use inverse cosine. For C, you just have to use inverse tangent. And then for D, you would use a similar trick that you used for part B. Except this time, since it's secant, right, it would be cosine, not sine. Okay, so that's it for today's lesson on solving trig equations. In these next couple of days, we'll be looking at some more, some more complicated equations that require a few more steps than the steps that we were looking at today. But otherwise, as usual, let me know if any questions pop up, whether you want to leave me a comment in the classroom, send me an email, let me know during class, whatever you feel most comfortable with. But I hope this lesson went well. Otherwise, I hope you guys stay safe, and I hope you enjoy the rest of your days.